So yes.
So yes, hello everyone.
So yes, today I'm here to record a lecture for describing motion part. Okay. So basically, let us quickly start about the motion part. But let me introduce myself. Myself, Anamika Dubey, and I've been teaching physics for last 10 to 11 years, and I've been mentoring students since 12 years. Currently, I'm working with LM Career Institute, and I'm working as a physics faculty competition coordinator. Okay, and I deal with the Olympiad section as well. Fine. So let us quickly begin with the topic. First topic is motion. Actually, this topic is currently updated as describing motion part in class 9 physics by CBSE. And we are going to learn exactly the same thing, only the name has been updated. So what is motion? Motion means change of position. Motion means change of position. Okay, change of position with respect to time. With respect to time. Okay, anything which is moving is said to be in motion. Okay, and with respect to time. So now why do we study motion? Okay, we study motion because we have a part of physics that is called as mechanics. Okay, we have a part in physics that is called as mechanics. In mechanics, we have two more bifurcation, that is kinematics, and other is called as dynamics. Kinematics and dynamics. Now, what is difference between two? Understand. In kinematics, we are going to study what are the things change that whenever there is a motion in the object. For example, if any object is moving, what happens to speed? What happens to velocity? What happens to distance, displacement? With what values they change, and how can we calculate the change? So these are the various things we are going to study in kinematics. And in dynamics, we usually focus why there is a change. Okay? So basically, this why we are going to study in dynamics. Currently, हम kinematics पढ़ रहे हैं, so we are going to focus on kinematics. So now quickly, let us delve to the topic without wasting any time. Okay, these are the important topics that is there in your syllabus. Okay, currently, so I have explained well about kinematics. Now let us understand, before learning kinematics, we have to learn the application. Kinematics objects पे applied होता है, right? So now we are going to study two types of object. Okay, one object is called as point object. Okay, and other object is called as extended object. Okay, point object and extended object. Okay, why point object, extended object? Point object can be defined into two parts. पहला, the object is actually point. Actually point मतलब क्या होता है? It will have no dimensions. It will have no dimensions. I hope you know the meaning of dimension. It will not have considerable length, breadth, height, but it will have mass, right? अगर मास नहीं होगा तो वो एग्जिस्ट ही नहीं करेगा. तो पॉइंट ऑब्जेक्ट का पहला पार्ट है इट द एनी ऑब्जेक्ट विच इज एक्चुअली अ पॉइंट दैट मींस इट विल हैव नो डायमेंशन बट इट विल हैव मास. ओके, एंड व्हाट इज अदर पॉइंट ऑब्जेक्ट? अदर पॉइंट ऑब्जेक्ट का डेफिनेशन क्या होता है कि ऑब्जेक्ट के पास कंसिडरेबल लेंथ होता है, ब्रेथ होता है. ऑब्जेक्ट विल हैव लेंथ, ब्रेथ, हाइट. ठीक है, लेंथ, ब्रेथ, हाइट, बट इट अपियर्स टू बी पॉइंट. ठीक है, अपियर्स टू बी पॉइंट. व्हाट डज दैट मीन? Understand this part. I hope you know that this is a Google map. This is a Google map. See, you can see various location on the Google map. Here, these locations are actually not point. They are appearing point. Why? Because these locations are being traced from high above satellite. Okay, so they appear to be point. They appear to be point. मतलब how does it make sense? Understand. Okay, understand. See, if the dimension or size of the object, if the dimension or size of the object is much smaller than the distance from where it is being observed. I repeat, if the size of the object is much less than the distance from where it is being observed. Simple thing. If the object is on Earth, if the object is on Earth, but if it is being observed from satellite, I hope you know the distance between the object and the satellite is much more than the object's own size. Okay? So if the size of object, okay, if the size of object is much smaller than the distance from where it is being observed, Distance from where it is being observed. So that object can be considered as a point object. Okay? So Google Maps, tracing locations, all are based on this phenomena that they are tracing the location via satellites. And thus, we are not point, the train is not point, auto is not point, even the buildings are not point. They are having considerable length breadth, na? But that is with respect to us. But from the distance, from satellite, they are appearing very, very small. So that is a small point object. Also, the very important thing, whenever you're flying high in the aeroplane, you can see the buildings very short. Okay? So actually they are not short, na, but you are observing from large height. So it appears to be point. Okay? I hope it is clear. Now other type of object is extended object. Extended object means it will have length, breadth, height, and it appears to have a considerable height, breadth, or length or size. Okay? Now, how do we describe motion? Okay, how do we describe motion? Understand. Now, if I tell you a story over here, you can see if I'm making a tree and here is a bus. Here is a bus and here there is a person who is sitting on a chair. Okay, now understand. For this person, the tree is at rest. But for this person who is in bus, the bus is moving here. Okay, right hand side. So for this person, tree is moving left hand side. Tree is moving behind. So in short, for this person, the object can be at rest, but for other person, the object can be in motion. So at the same time, any object can be considered at rest and motion both. So we cannot specify the state of object. We can say the object can be at rest and motion both at the same time, but it depends on who is observing. Okay, it depends on who is observing. That is frame of reference. Frame of reference. Who is observing means frame of reference. मतलब किसके reference में बात की जा रही. Okay, I hope it is clear. Now we are done with. Now let us know about the quantity. We know what is speed. Speed is distance upon time. I'm just doing a quick recap. Speed is distance upon time, distance per unit time, or it can be defined as rate of change of distance. And what is the unit? Unit of speed is unit of distance upon unit of time, right? If you want to calculate the unit of speed, speed ka unit will be distance upon time ka unit, and distance ka unit we know it is meter per second. So unit for speed is meter per second. Okay, SI unit is meter per second and CGS unit is centimeter per second. Okay, we have one more unit FPS, but that is not required here. Okay, now understanding few important concepts. Speed, we know speed is a scalar quantity. Okay, speed is a scalar quantity. What does it mean? It is independent of the directions. Okay, it does not have to do anything with the direction. But now, if I am asking you this question, what is different between the following? The plane is flying at a speed of 30 meter per second and the plane is flying at a speed of 30 meter per second towards north. Understand it? Towards north means what? It is a direction, right? Towards north is direction. That means now we are associating speed with direction. Now we are associating speed with direction. Okay? Understand? We know speed is distance upon time and velocity means speed with the direction. Speed with direction. So we can say कि velocity is displacement upon time. Okay, velocity is displacement upon time. And what is the unit? Unit is same. Unit is meter per second because we know distance is what? Distance is the total path covered, path taken to move. Okay, and displacement is the shortest distance. Displacement is the shortest distance. What does it mean? If a person moves from A to B and B to C, okay, B to C, so here the total distance is AB plus BC. So that will be total distance. Okay. But if I'm talking about displacement, what is displacement? It is the shortest path between A and C. So you can see the hypotenuse. If I'm making this is a right angle triangle, this is the hypotenuse. Okay. So displacement is having a simple formula, final position minus initial position. Okay, I hope you people know about it. So this is velocity displacement upon time. Now coming out of the new topic called as acceleration. Now what is acceleration? Acceleration is change of velocity upon time. Change of velocity upon time. Now understand, it is not velocity upon time. It is change of velocity upon time. That means understand the situation. If I am telling there is a boy, okay, there is a boy who leaves from home to school, okay, every time, and it takes 10 minutes for the boy to reach the school. How? In between there is a signal. In between there is a signal. So the boy goes 5 minutes from home to the signal and then 5 minutes from signal to the school. Okay, and the boy goes from cycle. The boy goes from cycle. Now understand, suppose on a single day, unfortunately, there is a traffic and the boy spends 8 minutes here only. So, now there is only 2 minutes left to reach the school. Okay, only 10 minutes gap he is having. So, to reach the school in 2 minutes, the boy will have to increase the cycle speed, right? Increase the cycle speed, and obviously the direction is changing in motion. So increase in speed with direction, that means the boy has to change its velocity. Okay, that means you can understand in short, the first part it was having a velocity called as u, and later on it was having a velocity v. Now what is uv? U means initial velocity and v means final velocity. Okay, and obviously there was a change of time. Okay, the boy kept on changing the speed. The moment he is getting late, he will try to increase the speed with respect to time. Like with time will pass on and speed will also change. So now here comes a new part, that here the boy was actually accelerating. The boy was actually accelerating with the bicycle. That means acceleration is change in velocity upon time, or change means what? V final minus V initial upon time. And we know for V final we'll write V, and initial we write U upon time. Okay, so acceleration is having this formula. And what are the unit of acceleration? It is meter per second square. This is the unit for acceleration. Okay, I hope you have understood acceleration unit. Now we are going to learn very important term called as motion. Uniform motion and non-uniform motion. Okay, we have uniform motion and we have non-uniform motion. So what is uniform and non-uniform motion? Okay, the motion is in a simple, very simple terms. I'll tell you in a very simple term. एकदम easy terms में I'll explain it. Okay. Now understand, the boy goes from point A to point B. Okay, boy goes from point A to point B, and this is 5 meters. Okay, so boy goes first 1 meter in 2 seconds, another 1 meter in 2 seconds, another 1 meter. Similarly, I'm going to divide it into 5 meter into 5 parts. Okay, so for every 1 meter, it is taking exactly 2 seconds. So if the boy takes or covers equal distance in equal interval of time, okay, equal interval of time, then the boy is said to be having uniform motion or uniform speed. Okay, that means in non when the object covers equal distances in equal interval of time, the object said to be in uniform motion. Okay, and here in non-uniform motion, it may cover distance to be unequal or time. For example, if I am considering distance 1 meter only, 1 meter, 1 meter, and again 1 meter for 5 meters, he may cover first 1 meter, 2 seconds, then 3 seconds, then 1 second. That means here the distance is same, here the distance is equal, but the time is unequal. Or we can say it can cover unequal distances in unequal time, equal distances in unequal time, or vice versa. So that will be a non-uniform motion. Okay. Now, if we are studying uniform, non-uniform motion without discussing the graph, we cannot solve it. Okay. Now, if I'm drawing a graph like this, okay, just a second. Yeah. So if I'm taking this graph, I'm drawing this graph here. Just, yeah. Yeah. So if I'm drawing a graph here, okay, if I'm drawing a graph of uniform, non-uniform motion, you can understand if the motion is uniform, how to identify motion is uniform, non-uniform. If the distance versus time graph of velocity versus time graph is a straight line, it is a uniform motion. Okay, and in non-uniform motion, it will be curve. It will be curve. Now understand, this graph is for increasing velocity or increasing speed. Okay, see, the time is increasing and the distance is also increasing. Or if I'm plotting velocity here, time is increasing, velocity increasing. So both are having the coordinate here. That is the reason the graph is like this. Okay, and in non-uniform motion, it will be curve. Okay, now this is increasing part. But if it is uniformly decreasing, means obviously the motion can increase the speed uniformly or it can decrease the speed uniformly. Okay, so if it is decreasing, it will be uniform motion, straight line, but in decreasing terms. Okay, and what about this? Non-uniform decrease will be like this. Okay, this is very important part. This is very important part. Okay, so I hope you understood uniform, non-uniform motion within graph. Now one last topic and we are going to solve 2 to 3 questions only. Okay, for example, if I'm asking you uniform motion, we can have uniform acceleration. Uniform acceleration and we have non-uniform acceleration. Okay, non-uniform acceleration. Now understand. What is uniform acceleration? Uniform acceleration means what? I'm writing the formula for acceleration. Acceleration is rate of change of velocity. This is rate of change of velocity. So if the change every time is equal, okay, is uniform, then the acceleration is uniform. Okay, and if change is not uniform, it will be non-uniform acceleration. Okay, for example, if acceleration is v minus u upon t, every time the change in v with respect to time you're solving, you're getting every time 2 meters per second square and next value is also 2 meters per second square. So acceleration is uniform. Okay, and non-uniform you will have another value like 2 and next time you're going to put another uv value, you will get 3. Next uv value, you'll get something different. So that is uniform, non-uniform. And when there is uniform acceleration, we have to study 3 rules. Okay, 3 equations. Those equations are the building blocks of your kinematics, especially for class 11th and 12th. Okay, so you have to remember it like this. VTS, first relation, V is equal to U plus AT. Okay, it shows the relation between velocity and time. Okay, so if the question is, if the object is moving with so and so velocity, if the object is moving with 50 meters per second, what time it will reach? So here they are associating velocity with time, right? So this is velocity time equation. Second is S and T relation. Okay, so S is equal to UT plus half AT square. And third is the V and S relation. So we have V square is equal to U square plus 2AS. This is strictly equation 1, this is 2 and this is 3. You have to remember the sequence. This because you cannot alter the sequence right here. Okay, so I hope you have understood. Now let us solve few questions over here. Understand. A car is traveling 20 meters per second along a road. Child runs out on the road 50 meters ahead and the car driver steps on a brake pedal. What must be car's deceleration? Okay, let us understand. Deceleration means what? Deceleration means what? Deceleration is negative acceleration or it is called as retardation. Okay, negative acceleration we will discuss somewhere when we are going to solve it. Okay. Now there is a car which is already traveling. So let me tell you, this is the speed 20 meters per second. Okay. Now it runs out, the child runs out of the car 50 meters. Suddenly there is a child, okay, which runs out of the car 50 meters ahead and the driver stops the car. So what is the velocity, final velocity? G. Okay. So they are asking you what is deceleration. In short, they are asking you acceleration values. Okay. Now, what are the parameters we have? We have U, V, and S. So, which is the equation? We have the third equation, relation between velocity and S. So, U square plus 2AS. So, V square is 0. U square is 20 ka square plus 2 into acceleration they are asking. And we have the distance 50. So, when you are going to solve, you are going to get is 400 plus 100 into A. So therefore, it is minus 100A is equal to 400. So therefore, acceleration is minus, you'll have 4 by 10. So that means it is Just a second. Let me do it. Okay, so it is 2 by 5. So here what is the acceleration? The acceleration here is 5 to the 10. It is 100. Okay. So acceleration here is 400 by 10. Sorry, it is 4 meter per second. It is 4 upon minus 100. So acceleration is minus 4 meter per second square. And we know what is retardation. Retardation is negative acceleration. Retardation is negative acceleration. So we have negative minus of minus 4. So answer here is 4. Okay. So this was just an example. Okay. For retardation is this. Now let me ask you one important question. We have certainly, if the speed, what would have happened if the speed was 20 kilometer per hour? In this case, you have to convert by simply multiplying by 5 by 18. Okay. 20 into 5 by 18. जब आप इसको solve करोगे, you are going to get some answer like 2 9 the 18, 2 10 that, and it will be 50 by 9 meter per second. Okay. So apart from calculations, if there is any mistake, it is fine. But rest of the thing, the concept will be clear. If there is any mistake, it will be only in the calculation part in the mathematical section. Okay. Baki rest of the things, it is all clear. Fine. So one more question let us solve, and then we are going to do one more question. Average velocity, we can do it. These are the rest graphical part. Okay. So yes, let me solve one more question. Okay, one more question. Particle moves along a side A, B, C, D of side 25 meters. Okay, so side is 25 meters each, and it is a square with a velocity 15 meter per second. They are asking you average velocity. Okay, average velocity का concept I have not yet thought, but understand. Okay, average velocity formula is total displacement upon total time taken. Okay, total time taken. So total displacement, here we have to find total displacement and total time taken. So here, okay, they have given you the velocity 15 meter per second, its average velocity. Okay, fine, understand. Here, you know, the objects start from moving this part, A to B, B to C, C to D, okay, and it has stopped over here. Okay, it has not completed its complete round. So what is the displacement here? Displacement I have told is the shortest distance. So it is final position minus initial position. So final position was D minus N. What is the gap between D minus A? Actually the length of a square field. So I have taken total displacement 25. Now I have to find the time taken. How do we find the time taken? Understand. Here the object has started A to B, B to C and C to D. So here it went 25 meter, 25 meter, 25 meter. Okay? And with a velocity 15 meter per second. So here if I'm telling you, what is the velocity? Okay? What is the velocity? Or if I'm telling you what is speed? Speed is what? Distance upon time. So distance here it has covered 75, 25, 25, 25. Upon time taken, I don't know. What is the value? I don't know. It is, I'm writing here time taken. Now understand why I'm using this formula. Because in the question it is giving velocity. Whenever two concepts. First concept I like to tell you that whenever object is moving in straight line, the velocity and speed is one and the same. And second concept I like to tell you, because I have to find the time taken, I know whether I consider velocity or whether I consider speed. Time taken will be same for both of them, right? So time taken will be same for both of them. So using this formula, I can find out the time taken. The speed I'm taking here, I'm taking the value of velocity mentioned in the question, 75 upon time taken. So therefore, time taken will be 75 divided by 15. And it will be 15, 3 the 15, like 5 3 the, and then 5 and the 5 and 5 is something. So answer is 5 seconds. So here I'm taking time taken of 5 seconds. So 25 by 5. So the average velocity will be 5 meter per second. Okay, it will be 5 meter per second. What is the answer? It is the 5 meter per second. So I hope you have understood this part. There are many concepts to be done over here. Okay, there are many concepts to be done over here. But currently, in short, this is what we have I've tried to explain you all. For later of the concept, we'll connect. Okay. So yes, take care everyone. Bye bye.